Okay, today we're going to look at volumes by rotation. We're going to start with a linear function. Okay, we need to find the equation of this particular linear function, and I'm going to have this x-intercept be at the point h0. I'm going to have this y-intercept where this same y value as the top of this function is going to be at the point 0r. So what I am doing is I'm creating the coordinate on this linear function at the point hr. Okay, we also see that it intersects at the origin. Okay, now the area that we have created underneath this linear function in between the line x is equal to h and then the line y is equal to 0 is now this area in here, and we're going to revolve that area around the x-axis. Okay, so our mirror image will be down here. Okay, and as we have already discussed, this will definitely be discs that will make up this volume, and one of the discs would look something like this, okay, where the radius is that distance right there. So we know that an area of a disk, or an area of a circle, is equal to pi r squared. So what we need to do is find out what our radius is, and we can see that since this is revolving around the x-axis, all we have to do is worry about the distance that the function actually creates. That'll be your radius. Okay, so we need to know what the equation of this linear function is. Alright, so I'm going to put this in point slope formula or form. Okay, I'm going to use the origin as my x1 and y1. Now we need to know what the slope is, and that's literally just y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So it is going to be r over h. And then if we clean this up a little bit, y is equal to r over h times x. That is actually our linear function, and that's what we want to use. And since it is our linear function, it is our radius as well. Since that is the case, we can go ahead and substitute that into our formula up here for r. Okay, and we'll go ahead and clean up the powers here. And that's going to be our area function. Okay, we know that the volume of this particular object is going to be the sum of each of those discs, and we want to do that, and we're going to have to use an integral, and we've already discussed this as well. Okay, so the volume in this case we know is going to be, like I just said, the sum of all of these areas. Now what we need to know is what is our lower and upper bounds, and as I go back and we look at the picture, we're going to start right here. Our first disc will be down here at that point, and the last disc will end up when we get to that x value. Okay, and so our lower bound is going to be this x value 0, and our upper bound will be this x value h. So we're going to go from 0 to h in this particular integration. Okay. The interesting thing about this is we're going to treat r and h as constants. Okay, that's what we denoted them as. And so when we do the antiderivatives of this, we're going to treat this as a constant, and then the antiderivative of x squared is 1/3 x cubed. So this volume then is going to be pi r squared over h squared, and then times 1/3 times x cubed. Okay, and we're going to go from lower bound 0 up to upper bound h. Okay, if I clean that up a little bit here, we got pi over 3 and then I'm going to write it as r squared over h squared times x cubed. Okay, and then now, as we know, we're going to substitute this h value in for x using the fundamental theorem of the calculus, and then we're going to also put in 0, but since 0 is going to be substituted for x, that will make that entire value 0. So really all I have to do is worry about the h. So we're going to have that, and as we can see, we're going to have h cubed over h squared, and so what we are left with is volume is equal to pi over 3 r squared times h, which, how about that? That is the volume of a cone. And so what we have just done on this particular problem, the way I set this up is with this linear function, and that is indeed a cone. We have derived the formula to find the volume of a cone. So now you can head down to Whitey's, fill up your waffle cone with ice cream, and you should know exactly how much you have in there.